So many stars exist in the universe, but there are some that are so powerful and massive that they are referred to as superstars. Superstars are not your favorite celebrities that are loved on a global scale. They are behemoths of the universe because of how dangerous they are to the Earth, with the unique substances they produce. We'll be taking off into a part of the universe called superstars and the deadly elements they create. But first, when superstars were first discovered, the astronomers leading the research, Feast and Thackeray, named them supergiant in 1956. After studying the stars further, they chose to call them hypergiant. These stars are categorized by their characteristic broadening and red shifting of their spectral lines, which makes them produce a distinctive spectral shape known as P Cygni profile. These stars are classified by their luminosity. However, another astronomer called Keenan suggested that the term hypergiant should be used differently from supergiant. The main reason was because hypergiant stars shine brighter than supergiants. And till this day, many scientists run with this theory. But how exactly were these superstars born? Well, just like all stars, they were born from clouds of gas and dust. No matter how the end result comes out, the process takes millions of years, but the stars turn on when hydrogen starts to fuse in its core. With the fusion of hydrogen, it moves on to a period of time in its evolution called the main sequence, which is when the star stabilizes and the outward pressure from the core of the star is balanced. The star is born after this process, and the hydrogen starts to fuse into helium. Hypergiant stars are born when stars exhaust all their hydrogen and begin to expand, becoming larger supergiant stars. Some studies show that the Sun will do the same thing in the future, but it will not grow as large as hypergiant stars. Let's go back to the hypergiant stars. Superstars or hypergiant stars don't just experience their transformation on the outside, they also expand on the inside too, as the helium formed from the original hydrogen fuel starts to fuse into carbon and oxygen. The fusion then makes the star start to heat up from the inside, leading to swelling on the exterior part of the star. Even though this process seems like it could destroy the star, it actually does the opposite by ensuring the star doesn't collapse in on itself. The color of a superstar depends on the size of the star. All superstars grow at different rates when they start to use other elements in their core, so they can sometimes appear as yellow, red, or blue. But the major reason for these rapid color changes is that the stars are losing mass rapidly, which makes them shine brighter, signaling that the superstar is aging. The most intense process of aging by superstars is experienced by the stars that grow over 100 times bigger than our Sun. The largest superstar is 265 times bigger than the Sun and is incredibly bright, which is what made scientists give it and its counterparts with similar characteristics the name hypergiant. But as impressive as these stars are, they also produce dangerous elements, which can destroy the Earth if they ever fall towards us. While some of the elements produced by these stars can be found on Earth, their use cases in superstars are different and can be more lethal to the universe. One of the elements produced by superstars is iron. On Earth, iron in the human body produces hemoglobin to transport oxygen in the blood. But in superstars, iron is produced in the star's core towards the end of its life. The presence of iron in a superstar means that the star can no longer sustain fusion, and it would lead to the formation of a black hole. The second element produced by superstars is cobalt and nickel. These two elements signal the end of a star's fusion abilities, and because they are radioactive isotopes, they emit harmful radiation when a star decays. If you don't know what radiation can do, maybe we should look a little at Maria Curie. After she discovered uranium, the radiation she was exposed to led to her death after making her sick for days. The notebook she worked with during her research cannot be used even to this day because of the radiation they were exposed to. Speaking of radiation, superstars also produce uranium and thorium, which are capable of emitting intense radiation over millennia. It simply means if a superstar producing uranium or thorium collapses, the radiation that will be emitted will remain in space or wherever it lands for years on end. Hypergiant stars also produce radioactive isotopes like carbon-14 or C14, which can interfere with planetary atmospheric chemistry. They also produce cosmic rays, which can not just damage planetary atmospheres, but can also destroy biological life and electronics. The most dangerous thing produced by a superstar would be a black hole, which can come from the star collapsing, leading to the formation of accretion disks that emit dangerous X-rays and gamma rays. Despite all the dangerous things produced by a superstar, they all don't exist in a vacuum. They are usually triggered by a phenomenon called supernova or supernova nucleosynthesis. When a superstar starts to lose its ability to fuse with other elements, it starts to collapse in on itself, leading to a supernova. This is a phenomenon that leads to the production of elements in the core of the star that could not be produced during its life cycle, and these elements are heavier than iron. A supernova occurs due to different factors like extreme pressures, temperatures, and neutron densities. There are 3 stages before a supernova occurs. The first stage is called the core collapse supernova. It starts when a superstar undergoes fusion in its core until iron is produced. Once the iron accumulates, fusion stops because iron cannot release energy through this process. It then leads to the collapse of the core under gravity, triggering a shock wave and a supernova explosion. The second stage is explosive nucleosynthesis, and during the explosion, shock waves pass through the star's outer layers which provide for rapid fusion. This leads to the production of light elements like silicon, sulfur, calcium, and some other elements that are as heavy as or heavier than iron. The third stage is elemental enrichment, which is when a superstar's explosion ejects newly formed elements and enriches the surrounding gas and dust. This stage leads to the formation of new stars, planets, and life. But not all supernovae lead to the production of elements. Sometimes they lead to black holes, and these structures can lead to the destruction of whole planets. What exactly are black holes, and what kind of substances? Although black holes are formed by supernovae, they are more dangerous. They defy the laws of physics through their strong gravitational pull that no planet or entity can avoid once in close contact. Black holes don't necessarily produce elements because they absorb energy instead of emitting it, but there are some exotic substances associated with the presence of black holes, like strange matter, which is formed through electron and neutron degeneracy. Another exotic substance formed from black holes is quark-gluon plasma, which is formed when the pressure mounted on a black hole overcomes nuclear degeneracy and matter breaks down in quarks and gluons. While these substances are being produced in outer space, they can still have drastic effects on Earth. A potential risk that supernovae and black holes can pose to the Earth is radiation exposure. It's believed that the Ordovician mass extinction from 450 million years ago happened because a superstar burst and led to gamma-ray exposure. A supernova could also lead to a blast wave, which can strip the Earth's atmosphere or bombard us with debris. Superstars are light years away from bursting, but what can scientists learn from them now? What can scientists learn from superstars? Through studies on superstars, scientists can learn about the evolution of massive stars, which can help scientists find out how they transition from their main sequence to their final stage. Astronomers can also learn new ways to understand the existing models of stellar stability, since hypergiants push the limits of modern physics. Also, scientists can learn about cosmic evolution, because hypergiants show how galaxies are formed. Superstars can show us how life is formed and what dangers the world could face if they burst. They also teach about how certain elements we can't directly interact with behave, and how the cosmos evolves over time. A look into superstars can reveal more about the beginning of the world and more information that is shrouded in mystery. What else do you know about superstars? Let us know in the comments.